Okay, let's dive right into this explainer and figure out exactly how to crack the code on those, slightly intimidating algebra word problems. If you've ever stared at a massive paragraph of math text and just felt completely lost, hey, you're in the right place. Today, we're going to completely change the way you look at those problems forever.
We've got a really clear roadmap for our mission today. We're starting off with the math code breaker, then breaking down the vocabulary, translating action words, the three-step method, running Nache comments, and finally, why this math matters.
Section 1. The Math Code Breaker.
Making a math expression out of everyday words is honestly just like being a secret agent with a decoder ring. The absolute most crucial thing to remember here is that word problems aren't gibberish, they aren't trying to trick you. Just like translating English to French, we're literally just taking everyday people words and translating them into precise math code.
Section 2. Breaking down the vocabulary.
Now, to translate effectively, we obviously need to understand our tools first. When we look at actual handwritten student notes, we can see the fundamental building blocks laid out perfectly. We've got variables, constant terms, and numerical coefficients. Let's break down exactly what those mean.
First up is the variable. I want you to think of this as your mystery number. Whenever you're reading a sentence and you hit a phrase like a number, well, that's your immediate cue to just pick a letter to act as a placeholder. We use N or X all the time, but honestly, any letter works. It's just a piece of the puzzle we don't know yet.
And we can brilliantly illustrate the difference between two other really vital terms using patterns. Imagine you're looking at a sequence of shapes. A constant term is kind of like a fixed shape that just doesn't change or grow as the pattern goes on. It's constant. On the flip side, the numerical coefficient represents the multiplier. It tells you exactly how much a shape increases in each new figure. So, in our code, the coefficient multiplies our mystery variable, while the constant just sits there, adding or subtracting a fixed amount.
Section 3. Translating action words.
Let's see how all this builds when we actually add some action to our mystery numbers. You can think of these action words as your personal translation map to figuring out exactly which math sign you need to use. If you see words like sum, added to, or more than, boom, your map points to a plus sign. Difference or less than, that means minus. Product or multiplied by signals times, and quotient or shared directs you straight to divide. Honestly, identifying these clues is half the battle.
But watch out, because getting the order right is often the absolute trickiest part of the entire process. Usually, you translate the math in the exact same order you read the words, right? Just left to right. So a number n plus 49 simply becomes n plus 49. Easy. But beware the special flip words. The biggest culprit for sure is subtracted from. If a problem says 66 subtracted from a number p, you do not write 66 minus p. No way. You've got to flip it. You start with p and take 66 away, making your actual math code p minus 66.
Section 4. The three-step method.
All right, so now that we've got our vocabulary and our translation map, we need a super reliable tactical approach to actually solve the code once it's written. Enter the three-step method. This is basically your guarantee for success. Step 1, substitute. When you finally figure out the value of your mystery number, you literally just replace the letter with that given number. Step 2, solve. Do the math carefully, making sure you follow the proper order of operations. And step 3, which, let's be honest, gets skipped way too often, verify. Check your work. Estimate the answer in your head or use inverse operations just to make sure your final number actually makes logical sense.
Section 5. Running Natch comments.
Okay, it's time to take our shiny new code-breaking skills out of the notebook and into the real world. Let's imagine the cost of gas at the Nache Commons Shell station is exactly $1.50 per liter. But wait, we don't actually know how many liters a customer is going to buy yet, right?
So L becomes our mystery number, our variable for liters. The baseline cost is our numerical coefficient 1.50 multiplied by L, giving us the expression 1.50 L. Now let's apply our translation map. What if the customer has a $10 coupon? Well, a coupon means a discount, so we subtract, creating the expression 1.50 L minus 10. But what if they want full service instead, which is an extra $3 charge? A charge means we add, giving us 1.50 L plus 3. Now if a customer pulls up and buys exactly 40 liters, we just use our three-step method. We substitute 40 for L, Solve by multiplying 1.50 by 40 to get 60, and then either subtract the $10 coupon to charge them $50 or add the $3 service fee to charge them $63. It's that simple.
To solve these real business scenarios correctly every single time, remember to just consult your map of phrases. A word like discount absolutely belongs in the subtraction category, right alongside loss and remove. A charge or a tax? Those belong firmly in the addition category. Keeping these synonyms straight is the true mark of an expert code breaker.
Section 6. Why this math matters. Now, you might be wondering why turning people words into math code is so incredibly essential outside of a math classroom. Well, let's ask a crucial question about how these algebraic concepts are actually applied to manage real, everyday businesses, like that gas station we just looked at.
The answer really boils down to consistency and fairness. By using mathematical expressions, groups like the Doig River First Nation, who manage the Nache Commons Urban Reserve Plan, can set up completely reliable systems. An expression like 1.50L minus 10 isn't just a random math problem. It's a hard business rule. It ensures that no matter who is working the cash register and no matter how many liters of gas a customer pumps, the rule applies perfectly, fairly, and efficiently every single time. It literally takes the guesswork out of the real world.
As we wrap up this explainer, I want you to remember that becoming a master code breaker takes practice. So if substituting variables or spotting those really tricky flip words felt a little difficult today, what is your specific goal for next time? Are you going to focus on hunting down that mystery number or maybe memorizing your action word map? Choose your strategy, keep practicing your translations, and I promise, soon you'll be reading math code just as easily as you read people words. Keep decoding.